In this video, I'm going to share with you a recent project that we completed that was to climate control an elevator equipment room. So this particular project had Samsung as the spec manufacturer, but this drawing here is what I made for our field installers to use as a reference. We had a controls contractor, an electrical contractor, and then us. So this building had 3 elevator cars here, and they go up and down with this motor and pulley assembly up in the equipment room. So the elevator car 1 was the largest of the 3, so that had a larger heat pump. I think it was a 3-ton for that. So I'm going to break down, what it took to install these heat pumps and how they work. So first and foremost, we've got an outside condensing unit here, which is number 1, and that corresponds to the indoor fan coil unit number 1 here as well. And then 2 lines up with 2, and 3 is lined up with 3. So in order for that to happen, we got to have power to each heat pump unit. So the tricky spot on this job was the electrical drawing showed power supplied independent to the outside unit and also independently supplied to the indoor unit. But that doesn't jive with the submittal for this equipment, where the power's got to go to the outside unit, and the outside unit serves as a power source for the indoor unit. So that ended up being something that we had to catch later in the game, which was tough, but anyhow, we got it right. So first and foremost, let's go on the power side. We got power panels up in this equipment room. Those power panels run to outside disconnects individually at each outside unit. That powers the outside unit, and then we'll zoom in here. So we have a single phase 208 serving the outside condensing unit. I'll zoom in on the wiring terminals here. So we got our L and our N terminals here. That's our power source in, and then coming out of that outdoor unit, so in this case it's number 1. If we follow that along, I want to say it was like 18.3 wire. Yeah. Alright, so we got 18 gauge 3 wire, which is our power from the outside condensing unit here. I'll zoom in on these terminals, and that lands at L and N as well, and then a ground. Okay, so that's the power. So when we shut the disconnect off outside, that kills the power to both the outdoor unit and the indoor unit. Okay, so the other would be, we have an indoor thermostat that's set very close to where the motor for the elevator is. So that's going to be your temperature reading for what that's at, and we'll have the fan coil unit set up to provide heating or cooling as necessary up in that space, because it is up on the rooftop. So we've got 18 gauge 2 wire that goes to the thermostat, and then we also have a controller that's mounted inside the panel for the fan coil unit. This controller here basically is taking that reading from the thermostat, taking the information from, so that thermostat is taking that 18.2 wire is tied into these F3 and F4 terminals and takes it back to the controller here. And this controller, each of these fan coil units has a controller here, and there is a backnet bus that runs through there. It's all daisy chained. There's some other equipment in that room that that BACnet bus is connected to, but basically it comes down, picks up the communication here, excuse me, and heads over to the master panel. And so that's how we can remotely control. Number one, we can see what the fan coil, what the temperatures are up there and what the fan coil is doing. But also we can set some parameters remotely as well as to, you know, what we want the equipment to do. So that's the purpose of the controls portion here. So the other controls portion of this is the control from the indoor unit to the outdoor unit. So in this, I'll slide over to number 1. So basically this 18.2 wire that goes from terminal F1, F2 has to get run to the indoor unit and terminate at the F1, F2 terminal right here on the indoor unit. And that's how the outdoor unit can communicate to the indoor unit. So we have power supply to the outdoor unit that comes through and powers to the indoor unit, but the power is not the same as the communication line. So that's just to energize the system power end, and then on the controls end, that's a separate wiring. So now on to the piping end. We have a line set here that goes from the outside unit. That refrigeration line set is suction and liquid, and it terminates to the indoor unit. So depending on what we are trying to accomplish, whether it's heating or cooling, that determines what that refrigeration cycle is doing. When we are trying to cool the space, there's also a condensate line here that picks up condensation that happens inside the coil here and gets rid of that. So as a quick takeaway to this, I would just make sure that if you're the responsible contractor for providing this, that you would have the controls contractor and the electrical contractor aware at for the power contractor, make sure that he understands that is the outside equipment feeding the indoor equipment, or are they run independent of each other. Then the controls then make sure that the right wires getting pulled from the outside unit to the indoor unit, because different manufacturers have different requirements on what they want. But anyhow, this was a Samsung product. I'll give you a zoom in on the models here. We had good luck with them. Simple startup, went great. Owner was happy. We were happy. So anyhow, thanks for watching.